So we'll start from sheet 1, question 1. Question 1 is asking us to verify. So it's saying let A be the following given set. 1, 2, 3, 4, 6. B 1, 2, 4, 6, 8. C will be 3, 4, 5, 6, 7, 8. And the inverse set is running from 0, 1 all the way up to 10. Now we must verify the following. Part A. Remember in the last class, I gave work for you guys to verify some laws. And I'd asked you to submit, but I think only one did submit. So what happens is, let's go to A. So A is 1, 2, 3, 4, 6. Intersection. Now we get B intersection C. So B intersection C, we look at what is common in B and in C. So we have 4 appearing here and there. We have 6. We also have 8. So we have 4, 6, 8. So now we can answer the question. What's the first set intersection, the second one? So we see there's only 4 in here and in here. Then there's 6, there's 6. So it's 4 and 6. That's what we have as intersection. Now the question is this thing the same as, so we pick the left-hand side. We just want to verify if this is the same as A intersection B, intersection C. So now we'll get A intersection B first. As you can see, we have 1, 1, 2, 2, 4, 4, 6, 6. So we have 1, 2, 4, 6. Intersection C, which is 3, 4, 5, 6, 7, 8. So let's see what's common. We have 4 here, we have 4 there, 6, 6. Only 4 and 6. So that means that we have verified that A intersection B intersection C is equal to A intersection B intersection C. Like that. So that's how it's coming out. Do we have any questions there? Because I'm going to leave B and C for you to just prove the properties, since they are all involving the sets that we have there. Okay, just be careful in getting the complement. Remember, the complement is about the set you're dealing with versus the inverse set. Okay, so last year, question 1 was not very important of the tutorial sheet, but question 2 was utilized so much. It appeared almost everywhere. It appeared in the exam. It also appeared in the quizzes. So maybe we must have, maybe we must take keen interest because of its nature. It's an interval question. So let x run from -20 to +20, both included. And then A is -2, 9, and B is -5, 6. C -20, -1. And this one is union 8, 20. So that's our C. So X is acting as the universal set. So this is the universal set. Part A says, find X minus A. Now X minus A, if you wanted to change the minus, you would say X intersection A complement. So the definition of minus is intersection complement. So whenever there is minus, you would go for intersection complement. Okay. So now we have X intersection A complement. So what is A? So A is here. So we need its complement. So A complement, the complement of a set comes from its universal. So look at the universal. Whatever is not in A, but in the universal belongs to A complement. So we have -20 is not in A, you pick it the way it is in the universal. Comma -2. Now -2 is a starting left boundary of A and is not included in A. So we include it in the complement. Union, you include 9 again because 9 is not in A. So you include it in its complement all the way up to 20. Okay? So now we're going to have -20, 20 intersection -20 to -2 union 9 to 20. So you see, so that means that these pieces, they were all being extracted from X. So it means that the intersection will be the same pieces that we got from X. Remember, X is the mother for these intervals. So if you wanted, you can also visualize this on the number line, because in fact the question says for each of the following sets, find each of the following sets and then display it on the number line. So now we display the solution on the number line. So let's see how it comes out. First, I have the universal closed at 20. Also opening at -20. So now this is from -20 all the way up to -2. And then it jumps, starts from 9 all the way up to 20. So this is what we have on the number line. So let's look at another one. Let's look at B. B is D minus A intersection C. That is B intersection A complement and then intersection C. So we need to get B intersection A complement. So what is A complement? A complement is what we have here. Okay, so now I'm going to do this on the number line. So the universal set from -20 to +20. So you run from -20 all the way up to -2. Then you run from 9 all the way up to there. That's A complement. Then now I bring in B. So B is from -5. B is from -5 all the way up to 6. So from there included all the way up to 6. You see? So we're looking for the intersection, is it? So let's go and shade the pieces where we see 2 lines. So I see 2 lines here. I don't see any other 2 lines. So it means that this is the intersection. Then now we bring in C. C is -20 to -1 union 8 to 20. So again, I'm looking for the intersection. So let's go on the number line. I'll do another one. Yeah, so this is -20 to -1. And then from 8 to 20. Then from there, let's bring in -5 to 2. Let's bring -5 to to -2. Here. From there to there, both included. Okay. So we're looking for the intersection. So again, where we see 2 lines, we shade. So that is the intersection of this interval versus this interval is just -5 up to -2. Like that. Okay. Any questions? Any questions, guys? Oh, well, maybe you're not there. Are you there? Maybe let me ask this question. Are you there?
Yes, sir. Yes,
Okay. Let's do another question. Let's do part C. Part C says A intersection C complement. Okay, so we need to find A intersection C first. So what is A? A is from -2 to 9. Intersection C. C is -20 to -1 union 8 to 20. So we need to find this, then we'll look for C complement. The intersection, maybe now I can do a shortcut one. So we look at between -2 and -20. Which one is bigger than the other on the left boundaries? So you see that -2 is bigger than -20. So we pick -2 the same way it is with its bracket there, not included. Okay? Comma, between 9 and -1, we pick the smaller one. So we pick -1 with its bracket, union, the same interval. You go to the other one and do the intersection. -2 and 8. Which one is bigger than the other? So 8, and then 9 versus 20, 9 is smaller. You pick it the way it is. So this becomes the intersection for A and C. But the question demands for A intersection C complement. So we want to get the complement of this. So we just go to the universal set and say, okay, we can't see -20 all the way up to -2. Since it's included in A intersection C, it's not included in A intersection C, we include it in the complement. Union, we skip this interval. We start again at -1. Because -1 is included in A intersection C, we won't include it in A intersection C complement. So we'll have -1 all the way up to 8. Union, we skip. We start from 9 again. So 9 is not in A intersection C all the way up to 20. So this is the complement. We want to see how it looks on the number line. So the number line is here. So we have -20, we have +20. And then we have -2, we have -1 up to 8, then we have 9. So this part up to there, this part up to there, and this part up to here. That's how it looks on the number line. If you are used to shading, you can even be shading. You shade like that. You shade like that. So it's also fine to shade. And if you want, but if that's the final solution, so even if I just drew the line without shading, it will still make sense. Okay, so I'm leaving out for your exercise. You guys are doing, remember, you're doing one, part C. Question 2, you are doing D, E, and F. Since we've done A, B, C, you do D, E, F. Okay. Let's go to question 3. Question 3 says, given that the set of real numbers is the universal set, and then A is negative infinite up to 7, union 9 up to infinite. B is 5 up to infinite. Find each of the following and show them on the number line. A complement. So the universal set is a set of real numbers, which is from negative infinite up to positive infinite, like that. So A complement is going to be whatever is not in A, but is in R. So from negative infinite up to 7, we have no problem. But there's this part from 7 up to 9. It's not in A. And again, from 9, we go all the way up to infinite. So it means that this will be the only complement. Okay? On the number line, this time around we are doing this. Since the universal set is the set of real numbers, so there's a difference. When the universal set was from negative 10 to 20, we didn't have arrows on the baseline. But now, because it's the set of real numbers, what are we having? We are having arrows now. So we have arrows like that. Then we are saying, okay, it was running from 7 and then 9. So this is A. This is A. But now we want A complement. So A complement is open there, closed here. This part. This part is A complement. Okay? So let's go to B. B is A union B complement. So let's get A union B. So we have this union this. Union B. So B is 5 to infinity. Like that. Union means everything. So we pick from negative infinite up to 7. But as you go all the way up to 7, you find that, or maybe before we start writing them, let's put them on the number line so that we can see what we're getting. So we'll have up to 7 here to the left, and then from 9 go this side. Then from 5 here to infinite. Union means everything. So this part, we continue. So at the end of it, we have shaded everything. So the answer is R, the set of real numbers. Because we have taken everything. So that's how nice it becomes. So if I can't see just with numbers, I can come up with a number line and then do the demonstration. Okay. So on question 3, your exercise, you do C and D. So when I give you exercise, I expect to receive the answers latest the following day by 7 hours the following day. Because you will have classes the following day, and then we'll have our class at MAT19 or 20. So meaning that you won't have time to go through the work if you pack it. So I'd appreciate you do it, and then you do the submission. Okay, so this is specifically, this was MAT1120 sheet 1. Okay, bye-bye.